Good morning.
Good morning, sir.
Okay, thank you. So today, this is the last lecture of the unit number 3, information theory. So today we would be solve some numericals. Already I have taken one examples in Shannon-Fanon code and Huffman coding. Today we will take some other numericals. So this is the first question that is displayed on this slide. Please all of you note it down and take one pen and notebook for solving this numericals. So the first question says that consider a discrete memoryless source with 5 possible symbols where the symbols are xi, that is I is equal to 1 to 5, and corresponding probabilities are p of x1 is equal to 0.4, p of x2 is equal to 0.15, p of x3 is 0.15 again, p of x4 0.15, p of x5 0.15. Means the fourth time it is a repetition of the same probability, and only one time it is having the different probability. Now we have to find out the coding efficiency using Shannon-Fanon coding method as well as the Huffman coding, and then we have to give a remark which has given the better efficiency. So to solve this numericals, what we have to be done? First of all, you can calculate the entropy, because entropy is common for both either of the method you are going to use. Okay. So what is the formula for this? That is J is equal to 1, 2. Here it is a 5, so we have to take it a 5. Then P of xj log of P of xj, and here negative sign. When I am taking log of 2 P of xj, then a negative sign. Otherwise you can take positive sign here and 1 upon log of base 2 P of xj. So just put the values. The first probability is 0.4, that is multiply with, okay, one more thing, negative sign we have to also take in account. So for this purpose we would use a bracket equal to minus, this is a bracket we are going to use, log base 2 0.4, then point. One more thing, there is a rest of the 4 probability having the similar value of probabilities here. So we would directly count them. This is the rest of the number of messages of 4 multiply with the 0.15 log base 2 0.15. So it would be reduce the space and make the system simpler. So when you have to solve this, it is your task now. Using the calculators you have to solve it. So as log of base 2 is less than, here the values we are using, that is less than 1, so obviously it would be negative value. It is also negative, and negative would become positive. So finally you would get the entropy 2.17 bits per message. Okay. So up to this point, it is very much clear what you have to do. So you have to be always ready with your calculator, because in the examination it is required. Without calculator you can't be solve this numericals. Log base 2 or 0.4, 0.15, like this kind of the values would be not solved without calculators. So you have to keep a scientific calculator with you. Now this entropy is common for both Shannon-Fenton coding as well as the Huffman coding. Now we have to carry this for the next point, that the first we are going to apply the Shannon-Fenton coding. So case 1, here I would be write case 1, where we are going to use Shannon-Fenton coding. So what is the method of using Shannon-Fenton? We have to make a table where first column is message, second is probability, third one is code or code word, and then code word length. You can see code word length. Okay. So what is the first message? Now we have to arrange the message according to the decreasing order of the probability. So this is very much clear from the question. X1 having the highest value of probability, that is 0.4. I think yes, 0.4. Then X2 having 0.15, X3 same value 0.15, X4 and X5 is also having the same probability 0.15. Okay. Now you have to generate the codes for the corresponding value of the source symbols. Okay. So for this purpose, what is the method? We have to already arrange this according to decreasing order probability. Now we have to make a partition in two equal probable message. So if you have to see this first two having the value 0.65 and rest of 3 would be having 0.45. Okay. Otherwise you can take 0.4 and 0.60. But in the previous numerical we have seen that when you have to do the partition according to probability, and if there is not a chance of equal probable message, then we have to take the top one having the higher probability than the lower one. It would give you the better efficiency. So similar method we are going to use here. So we have going to do the partition here. Okay. So according to this partition, first of two message would be 0 0 and rest of would be 3 1 1 1. Okay. Now at the top of this partition or above of this partition, there is a two message symbols that could be further partitioned. So it would be again partition. So when you are again doing the partition here, it would get 0 and 1. And these two messages x1 and x2 would be not further partitioned. So it is the final value of the code word. X1 is 0 0. So length of code word is 2. X2 is 0 1. It is again 2. Okay. Now come to the rest of 3 message. And now again we have to perform the partition. So again we would do the summation. So this 2 would become 0.30. Okay. And this is 0.15. So again we have to do the partition here. So it would be 0 0 and then 1. Now again there is a chances of the partition here. So we would perform the same procedure of the partition. This is not need to write, only for understanding purpose. Okay. So it would be again the partition is there. So it would be 0 and 1. Okay. And last one is as it is, because there is no further partition is there. So again here x3 would be having 3 bits, x4 having the 3 bits, but x5 having 2 bits. Okay. So in this way we have generated the code words for the messages x1 to x5, as well as we have got the code word length, that is L. We have to find out the L from here. So you can use L, that is the average code word length. So what is the value of this? This would be, we know that k is equal to 1 to 5 here, nk and p of xk. Okay. So this is the number nk according to the value of k, and it is a probability. The first one is what? 2, and probability is 0.4 plus again 2, 0.15 plus 3.15 plus 3.15, and last one is 2 into 0.15. Okay. So when you have to be do this 0.8, then 0.30, then 0.45, 0.45, then 0.30. So you would be easily calculate this. So it would be become 0.8 plus 0.6 plus 0.9, then you have to become 9, 8, 17 and 6, 23. So it would be 2.3 bits per message, or letters per message you can say. Okay. So now in the channel panel coding we have average code word length, as well as we have already calculated the entropy, average entropy for the same. So we would be easily find out the efficiency. So what is the efficiency here? That is eta is equal to h of x upon L, and you can use this formula again, log 2 m. We know that we are doing the binary coding, so m is equal to 2, so it would be become 1. So here it is 2 point, what is h of x? If you remember, 2.17. H of x is 2.17, and what is the value of L? That is 2.30. Multiply with the 100, it would be come into the percentage now. So when you have to be divide this, what is the value is coming? Anyone tell me how much the percentage of efficiency? Just do the calculation till I would be enter into the case 2. That is Huffman coding.
94.34.
94.34.
34. Yes.
Okay. This was a efficiency according to Shannon-Fanon coding method. Now we have to become for the Huffman coding. So here again, what we have to be do? We have to be use the Huffman tree. Okay. So for this Huffman tree, I would first write the table, because the space is less here. In the next slide, I would be go for the Huffman tree. Probability and the code word and code word length. These are the four essential parts for this table: x1, x2, x3, x4, x5, 0.4, 0.15, 0.15, 0.15, 0.1. So what the code would become, we will be later on, come to later on. First of all, we have to be draw a Huffman tree. So see how to draw the Huffman tree. We have learned this in the last lecture x1. Again, arrange it in the decreasing order of the probability. Okay, 0.4, 0.15, 0.15, 0.15, 0.15. Okay. So what is the first step? We have to start from the lower end. So we have to start from the x5 and combine the two adjacent probabilities. So we have to combine the probability of x5 and x4. So in this way, x4 would be assigned as a 0 and x5 would be assigned as a 1, and the summation would be came here 0.30. Now, according to Huffman tree method, what we have to do? If the summation would become higher than the successive value of the probability or next upcoming message values probability, then we have to keep the summation above of them. So you can see 0.3 is larger than here dash you can use 0.3 is larger than the probability of the x2 as well as the x3. So what we have to do here, the space between x1 and x2 we have to write here 0.30. Okay. Now whatever the rest of the things we have to write as it is. You can write or you can use a dash also. Those who are not in the use, you can use the term dash or otherwise directly write the value. That doesn't make any change actually. So these two x2 and x3 are now available. Again, why we have to allocate the value of binary values 0 and 1 and do the summation of this, and this summation would be coming as 0.3. And again the situation has came when both the having the same probability, but whatever the latest summation, that would be keep higher as compared to the previous value. So here if you have to see, we have to use 0.30. Okay, and 0.40 here. Now we have to do the summation 0, 1. This is the dash here, or better way it is you have to write this little bit above. So it would be make a space. So you can write here x1 0.40 dash 0.40 dash 0.40 dash. Okay. Now 0.30 or 0.30 would be summation would be higher than the value of the 0.40. So we would make it goes to the above of this 0.60, and here as it is the 0.40 would be came. Okay. Now just do the summation. At the finally you would find that there is a probability of 1 would be came 0.60 and 0.40 1, and here when it would become the summation of probability is 1, here we have to stop. Okay. Now we have to do the reverse tracing and find out the corresponding value of the code word for x1, x2, x3 and x4. So what is the code word for the x1? If you have to see, this is start from here. This would be start from this point. So it is 0.40 throughout this is the 0.40. So the code word for x1 is 1. Similarly for the x2, it is start from here. Why? Because this branch is coming to this particular point. So now the tracing for the x2 is 0, then again this 0, because this is coming from this particular message, and then 0.15 like this. So what would be there? 0, 0 and 0. So 3 times 0. You can update this value here. It is as per this, it is 1 and it is 3 times 0. Then further we have to do the calculation. The next one is x3. Now we have to see the tracing path. Again, this is the tracing path 0.60. Then obviously this 0 is there, and then this 1 up to this point. Okay, so it would be 0, 0, 1. Okay, now come to the x4 and x5, that is coming from this branch, you can see here. Okay, so we have to see the path for the x4 and x3. Okay, so I just delete it so that it would be easier to understand. Now for the x4, it is 0, then 1, and then 0. So it would be 0, 1, 0. And the last one is x5. So what would be the path for this? It is 0, 1, then again 1. So it is 0, 1, 1. Okay. So we have to update this. X3 is 0, 0, 1. X3 is 0, 0, 1. X4 is 0, 1, 0, and x5 is 0, 1, 1. So what would be the length? 1, 3, 3, 3, and 3. Okay. So this is the updated value of the code word and the code word length. Now what we have to find out? We have to find out the average code word length. So you can write the formula for that. Okay. Tracing is just I have to show for understanding. It is also not necessary to write this here. It is not necessary to write here. Okay. Only you have to write the value on that table. But the slide is changed. That's why I have written like this. Now you have to find out the L. What is the L is here? So I am not writing the formula. You have to know that. So it is 0.4 multiply with the 1, then 0.15 multiply with the 3. So in all of the rest of the 4 codes, that is number of code word length is 3. So it would be further multiply with the 4 also. So for simplify this calculation, 0.4 and then 0.45 into 4. So it is 0.4 plus, so it would be came as L as 0, 2.2, 2.2 bits per symbol or letters per symbol. Okay. I hope all of you have understood up to this point. Okay. Now we have to find out the efficiency of this particular coding. So that would be came as the efficiency would be eta is equal to h of x upon L. Again, m is 2, so log base 2 is 1. So you have to find out this. It is 2.17 upon 2.2 into 100%. So what is the efficiency? Can anyone tell me what is the value of efficiency?
98.63.
98.63.
63.
Yes, 98.63%. So you can see now what is the conclusion. The conclusion is that Huffman coding is more efficient than Shannon-Fano coding. So this kind of remark you have to be right after this calculation. Then it would be give a better message to the evaluator. Okay. So this is the one of the example where we have compared the Shannon-Fano coding with the Huffman coding. Now see the another example of the Huffman coding. This is the second question. Consider a discrete memory-less source with 7 possible symbols, that is xi, I is from 1 to 7, and corresponding probabilities of this p of x1 is equal to 0.46, p of x2 that is equal to 0.30, p of x3 that is equal to 0.12, p of x4 having the value 0.06, and p of x5 0.03, p of x6 0.02, and p of x7 that is 0.01. Apply the Huffman coding to encode the message and find the coding efficiency. Now, why I have taken this question? Through this question, I would be tell you that Huffman coding is not unique in nature. Means you can perform this coding with the multiple way. So see the question. There are the two methods I would be going to use today to solve this particular question. Okay. So I hope all of you have complete this. Manisha Goshavi, ask your question. Any question? All of you understood the way that to solve the numericals based on this coding? Okay, there is no question. Okay. Now I would be solve this question, and then you have to understand with the two methods. The first one, the time is less, we have to be start. The first method. What is the first method for this? In both, we are using the Huffman coding is there. I would be tell you that what are the difference we are going to take. The first is symbol, then probability, then you can use the self information. It is optional one. If you able to calculate, you have the time, you can write here the self information that I have told you into one of the examples, or directly you can write the code word and code word length. It is a good practice that you would be use this section also, self information. You have to apply the formula of information and just calculate the amount of information for each symbol. So here there are the 7 symbols are there, and you have to be arrange these symbols according to the decreasing order of probability, and in question already it is given in decreasing order of probability, so it is very easy to arrange. But in sometimes that is not given in the decreasing order of probability. You have to be arranged according to the decreasing order of probability. Okay, so to remember this step, you have to be arranged the messages in decreasing order of probability. Okay, now this is the probabilities are given. Now we have to be find out the code word. So the first method I am going to use this to finding out the code word is, see the method. In this particular method, what we have to be going to do, x1, again arrange this x1, x2, x3, x4, x5, x6 and x7 as their decreasing value of their probability, and this one. Okay, now you have to be, what we have to start from the lowest value of probability and some add these two and assign the value 0 and 1, and what is the summation is coming 0.03. Now 0.03 is same as the probability of the x5. So what we have to be do, we have to be bring this 0.03 just above of this point, 0.03, sorry. Okay, and write this 0.03 as it is in its place. So you have to be at least keep the distance between the two corresponding values. If you are using the rule notebook, then you have to be clearly leave blank one line between successive value of the message. So it would be give you the clear picture and there is no jumbled information would be seen there. Okay, now we have to be see here 0 and 1 again and just do the summation. What the summation would be 0.06. Again it is larger than this. So what we have to do again, above of this you can just put up a dash, dash, dash and dash. This is the blank space. You can write directly this value also, so that you have to be not trace it up to the end. Okay, so here above of this we have to be write 0.06, and as it is usual 0.06 is for x4. Again we have to be apply 1 and 0, and when you have to apply you have to be write a dash like this. Okay, now again you have to be do the summation and it would be coming same as 0.12. So again do the same method 0.12 and here 0.12 as it is, and 0.3, 0.46. So again do the same thing 0 and 1. This would become 0.24. Okay, now this 0.24 is less than the 0.3. So what we have to do, 0.3 would be as it is its place, and here 0.24, and 0.46 would be as it is its place. Okay, and then again do the addition 0 and 1. It would become 0.54. That is 0.54 is larger than this 0.46. So it would be bring above of this 0.54, and 0.46 is below of that. Okay, and finally 0 and 1, and what is the summation of this? This would be came as a 1. So in this Huffman tree, what we have done, we have used the method that if the summation of two values of probability is higher than the next probability value, then we have to be bring it above than this probability value. That just like in the last case you can see. And another what we have used is the summation of the probability of the two messages are same as the next value of the probability. Then again also we have to be keep the summation output of the summation would be higher than the next value of the probability. Like in all the cases you can see we have do the same. So this is a more efficient method actually. That's why we have used this. Now what we have to do? We have to find out the code words for x1 to x7. So what is the code word for the x1 here? For ease of implementation, I am just writing here only. So if you have to see the x1 start from the 0.46, it is directly a straightforward. It is not moved anywhere. So it would be simply 1. Similarly, you can start to enter the attendance on the chat box simultaneously. Okay, now come for the x2. What is the x2 is there? This is, you can just trace it out. And this, so it is 0 and 0. Okay, so 2 times 0 would be there for the case of x2. Now for the case of x3, you can just trace it out as so what would be there? It is 0, then 1, then 1. So 0, 1, 1. Okay, there are lots of jumbled is there, so I have to just delete that one. Okay, now come to the x4. You can see 0.06 here. This is on the same line. Then again this would be come there. Then again it would be matched to this path. So what would be there? 0. If you would be see the path, so what would be the path here? It would be 0, 1, 0. Okay, 0, 1, 0, then 1, then yes, 1 is the last 4-bit message is there. Okay, so the last x5 one is x5. In the x5, if you would be going to trace 0.3 here, it would be goes here, then again in this path. So up to this part it would be same. So 0, 1, 0 would be common. Okay, and the rest of the things 0, 1, 0, then 0, and then 1. Okay. Now come to the rest of the path. So I just delete it so that it would be easier for you to trace it out. Okay. Okay, now see here. The next one is okay, x6. So x6, you can trace it out. Okay, the time is very much less. I would be just give you the values. Okay, we would be continue to the tomorrow's lecture. Now time is less than 1 minute. Or you have to be solve it your own. It is easy. Then we would be go to the second method, and then finally we will start the unit number 4. Okay. Okay. Thank you for all of you who are attending the lecture.